I'm Adam from RFOXiA, from our real lab. Today we're answering the question nobody in the wireless industry wants you to ask. What happens when your communication network belongs entirely to you, runs on Bluetooth and costs nothing to operate? There is a concept in networking that almost everyone accepts without examining it, the idea that communication requires infrastructure. That if you want to send data from point A to point B, there needs to be a tower somewhere in the middle, a satellite overhead, a router on the wall, a carrier collecting a monthly fee. This is treated as a law of physics. It is not a law of physics, it is a business model. Let's talk about what mesh networks and point-to-point BLE links actually are, and why the assumption that they require cellular infrastructure is not just wrong. It is the kind of wrong that costs people money every month for no reason. Bluetooth Low Energy was not designed for long range. The standard specification assumes a working distance of somewhere between 10 and 100 meters. This is accurate for the chips most manufacturers use. It is accurate because most manufacturers optimize for cost, battery life, and compliance checkboxes, not for receiver sensitivity. Receiver sensitivity is the ability of a radio to detect a very weak incoming signal. It is measured in dBm, and lower numbers mean better performance. A commodity BLE chip achieves around -90 to -95 dBm. That is adequate for a smartwatch talking to a phone in your pocket. The Multinav Pro Plus BLE module achieves -104 dBm. That 9 to 14 dBm difference is not cosmetic. In radio propagation, every 3 dBm roughly doubles your effective range. 9 dBm is approximately 8 times the range of a commodity chip. The physics does not care that the standard says otherwise. Now, point-to-point. This is the simplest configuration. One module talks to one other module. No routing, no relay, no network topology to manage. You pair them, they find each other, they maintain a link. Ground to ground with both modules connected to smartphones, this gives you 5 kilometers. Man to drone, where one module is elevated and ground reflections are reduced, this gives you 15 to 20 kilometers. Drone to drone, where both platforms are airborne and the ground is no longer interfering with the signal path, this extends to 50 kilometers. On Bluetooth, on unlicensed spectrum, with no license, no infrastructure, and no recurring cost. The data rate across this link is 2 megabits per second. That is not a low-power beacon rate, that is real-time telemetry, sensor streaming, control commands, and bidirectional communication at a rate that is entirely adequate for drone control, robot telemetry, and field data collection. Mesh is the more interesting topology for deployments that need coverage over area rather than just distance between two fixed points. In a mesh network, each node is both a receiver and a repeater. A message injected at node A propagates through nodes B, C, and D until it reaches its destination or the entire mesh has received it. This means a failure at any single node does not break the network. It means coverage expands as you add nodes. It means a sensor array deployed across a large agricultural field, a construction site, or a disaster zone can communicate internally without any of those nodes having cellular service. The applications for infrastructure-independent communication are not theoretical. Disaster response teams operating in areas where cellular towers have failed or been destroyed. Field robotics deployments in remote locations where building cellular infrastructure is not practical. Agricultural IoT across land that a carrier has decided is not commercially worth covering. FPV drone pilots who want control range beyond the 30-meter radius that commodity radio links provide. Researchers collecting environmental data in locations that have never seen a cell signal. All of these share one property. The conventional solution, cellular connectivity, either does not work or costs more than the application justifies. The infrastructure-independent solution works, costs nothing to operate after hardware purchase, and is legally usable on unlicensed spectrum anywhere the FCC or equivalent authority permits BLE operation. The RFOXiA BLE module is FCC certified. This matters because it means the hardware has been tested and approved for use in the United States, and because FCC certification is the primary credential distributors require before carrying a product. It is not a formality, it took time and cost money. It is the difference between a prototype and a deployable system. The RFOXiA Connect application runs the control side of this. It is a mobile application available on Android with iOS pending that pairs with the BLE module and gives you a PS5-style controller interface, a live GPS map fed by real-time position data, and sensor readings from the full module stack. It works completely without internet. When your drone is 40 kilometers away and the nearest cell tower is irrelevant, the app is still receiving live telemetry and transmitting your control inputs through the BLE link. There is also a mesh communication mode called BLE Chat. 2 or more Multinav Pro Plus users within range of each other can exchange text, data, and voice without touching the internet. This is not a gimmick. In a scenario where cellular infrastructure is unavailable, a disaster zone, a remote expedition, an area with deliberate signal jamming, a mesh communication layer that runs on hardware you already own and spectrum that costs nothing to use is the difference between coordinated response and isolated teams with dead phones. The question the wireless industry does not want builders asking is this: if the receiver sensitivity is the binding constraint, that is the underlying architecture. Now let me show you the actual hardware, what the module looks like, how it integrates, and what the full ecosystem connects to. This is the range claim made physical. The Multinav Pro Plus BLE module establishes private point-to-point or mesh links up to 50 kilometers. No towers, no carrier fees, no licensed spectrum required, your network, your terms. 2 megabits per second across that link. For a mesh or point-to-point deployment operating infrastructure free, that data rate means live drone telemetry, sensor streaming, and bidirectional control commands arrive without the latency that would make real-time operation impractical. The STM32WB07CC V6 is the chip doing the work here. It manages the BLE stack and runs user applications on the same processor, which means your firmware has direct access to communication state without the overhead of a separate host microcontroller arbitrating between them. 57 by 47 millimeters. The 140 millimeter antenna is the visible element that extends range beyond what any chip antenna can achieve at this size class. The fixing frame holes are positioned at 54 by 34 millimeters for clean mechanical integration into drone frames and enclosures. Infrastructure-independent communication only solves half the problem if the module cannot talk to precision location and environmental data. The Multinav Pro Plus ecosystem connects directly to the GNSS, sensors, and motor and battery management modules. One coherent platform, no adapter boards required. The RFOXiA Connect application is the control interface for this network. Live GPS map, real-time sensor data, a controller layout designed for drone and robot operation, all running locally on your phone, all functioning with no internet connection across the full range the BLE link supports. BLE chat extends the mesh beyond telemetry. When 2 or more users with Multinav Pro Plus modules are within range, they can exchange text, data, and voice directly. No carrier, no Wi-Fi, no internet dependency. In a disaster response scenario or a remote expedition, this is not a convenience feature. The firmware is open and programmable via SWD. For a module operating in infrastructure-free environments where the application requirements vary widely, agricultural, defense-adjacent research, industrial monitoring, full source access means you are not constrained by what the manufacturer anticipated you would need. The integrated RTC crystal provides precise timing independent of network synchronization. In a mesh deployment with no NTP server and no cellular time reference, the RTC is what keeps distributed nodes coordinated for data logging, event sequencing, and timestamp telemetry. Exists and is affordable. Why is every commodity BLE module on the market still sitting at -90 to -95? The answer is not technical. The answer is that the industry optimized for a different problem. The mission statement for this module is precise: a private, free, long-range communication network that belongs entirely to you and costs nothing to operate. That is not a marketing claim. That is a description of what the physics produces when you select the right chip and design the RF front end correctly.